What's up, everybody? Today we're going to be solving this example about the AB1 class distributions. So first way we're going to do this is with explicit computation. So we're given that the modified probability of 0 is 0.6. What we want to find is probability of 1 loss and 2 losses under the modified distribution. So for the explicit computation part, we're going to use our formula that connects this modified distribution to the underlying negative binomial distribution by scaling appropriately to make sure that all our probabilities still sum to 1. So what we can do is we can start plugging in exactly what we were already given. That includes this probability for 1, this probability for 0, which are found up here, and of course the modified probability of 0 losses, which we were given in the problem. So when we do that, we get the following. And I'm going to move this down so we have some room to express our answer. And with rounding to 6 decimal places, this comes out to the following when you plug this into a calculator. Next, we can do the same thing for modified probability of 2 losses with the original probability that we're given for 2 losses. And then again times that scaling factor, which is the ratio of that new modified probability of more than 0 losses to the old probability of 0 losses. Sorry, more than 0 losses. And when we put that into a calculator, this time we get 0.110752. And this is one way that we can come up with these answers. Another way is instead using the recursion principle of the AB1 class. So, first, let's find A and B. From our tables, we know A is the ratio between beta and 1 plus beta, which in our case is 0.5 over 1 plus 0.5, aka 1 over 3. We know that B is R minus 1 times beta over 1 plus beta, which we can recognize as R minus 1 times A, which in our case is 2.5 minus 1 times 1/3, or 1/2. And I'll be more explicit about that. That's 1.5 times 1/3, which is the same as 3 over 2 times 1/3, which is 1/2. You could also have just plugged this into a calculator and seen that the decimal is 0.5, and that also works just as well. So now we can compute the modified probability of 1 loss the exact same way that we did before, but instead of plugging it in again, I'm just going to bring it from over here, and we get that that's approximately 0.189860. Next, we can use the recursion principle to figure out what our modified probability of 2 losses is. And we know that this is going to be the probability of 1 loss under the modified distribution times A plus B over 2. And that 2 comes from this. So we can plug in what we have. That's approximately this value, 0.189860, plus our A and B. And when we put that into a calculator, I'll actually give you the intermediate step here. This is going to end up being 7 over 12. And we put that into a calculator to yield, to no one's surprise, the same result that we had before. So all 3 of these are valid ways to get the answer for the modified probability of 0, 1, and 2. Hope this helps.